All right, so thank you very much. Yeah, it's a very special day for me, not just because I get to talk about ZIO on this conference today, but also, yeah, I turned 50, and so there's my Twitter handle down to the right. So if you want to send me dinosaur memes or other bad jokes about my age, then please go ahead. So what I would like to talk about today is a use case that I developed in ZIO, and the idea of this talk is that I will tell you how I implemented this use case called ZMail using ZIO libraries only, right? And specifically, I'll be talking about the ZIO NIO, gRPC, and ZIO Config. And at the end, I'll do a very short demo, and we'll take a look at what we built. But before we move on, let me just tell you a little bit about myself. So you know my age, so that's a good start. But it really started back in 2001 when I received this letter from Sun congratulating on me on becoming a certified Java programmer. I attended Daniel's talk earlier this afternoon about how hard it is to unlearn certain things for Java programmers. Well, I've been through that. So after all of these years of Java, at some point I thought, well, there must be even cooler things out there. And my boss came up with this book, Scala for the Impatient. And I remember going through it and I thinking, well, okay, so they removed semicolons, what's the big deal? And didn't really think about it much more. And then at some point I ended up at Amsterdam.scala, the Scala user group in Holland. And there was this guy, John de Goos, or John de Goets, like how we would call him in Holland. And he was explaining this new ZIO library, and it looked kind of interesting. But still, I was a bit underwhelmed because this was the example. I was thinking, well, if this whole library, the only thing you can do there is to get somebody's name and to print it out on a console, well, that's what good is that going to do? But then I started looking into it and discovered there's a bit more to it than just printing stuff to the console. All right, so enough looking back. Let's look forward at present and what we can do with ZIO. So this is the use case for today. Imagine that you're a developer and you have to integrate some kind of email functionality in your application. And you need to be able to send out emails to your customers, for example, during an onboarding process or something of that kind. And you would like to be able to test it without actually sending emails to real persons, because you know, there might be wrong information in it. You want to integrate it in your testing pipeline and things like that. And so that's basically what I wanted to achieve, to mount some kind of service that would be able to receive an email and display it with some kind of web interface. And the idea would be is that this would run on some kind of server somewhere, and I would attach a domain name to it. And it would accept any kind of username. So you could send it to test at the domain name, and automatically a mailbox will be created for this user test. And when you go to that mailbox, which is out in the open, so it's not a very secure service, you will be able to inspect the emails that your system sent out, and you can see, well, the effect and check if they look okay. So that's the use case for today. I'm going to start at the left-hand side. So we're going to work our way through SMTP to gRPC to the front end. So let's take a look at SMTP in a second. Because first I would like to explain the title of my talk. So staying in ZIO. Why is that important? Well, I think if you've just also attended Adam's talk about ZIO cache, there are some advantages of being able to compose your application of things that are ZIO only. It integrates it more nicely. There's only one library to learn, of course, just ZIO. It composes nicely. Your error management will be the same from top to bottom. And also very importantly, there will be one single model to manage threads and concurrency and fibers and all these things. So you can be sure that the ZIO core will take off the concurrency for you. And under the hood, there will be several things happening to manage the concurrency. But if there's only one system doing that for you, then that will be enough. And it would be great if that one would give you enough functionality to get all the things done that you want to get done. So that's the main goal for today, to see what we can achieve with using ZIO components only. So let's take a look at the first part, so the SMTP service. So what should this be able to do? Well, it should listen to port 25, the standard ZMail port. and it should be able to initiate an SMTP conversation with some other mail service that's sending us an email, and it should be able to receive the email and then store it somewhere. Now, if you look at SMTP, so this is like a very super quick introduction to how SMTP works. So what happens is there's some kind of a client who wants to send an email somewhere to, let's say, the server, and they initiate the communication by knocking on port 25. And at that point, the server will have to respond with a response code telling a little bit about itself, like its domain name, and ask the client to proceed by identifying themselves. So, and then you can see it's an interaction between a client and the server. There are several steps. And in fact, this is a very well-defined protocol. There are RFCs who describe in minute detail what this communication looks like, which codes to use when, even the spaces and the brackets, when to put what where. And also the terms that you see here, like mail from : and RCPT to : they're all prescribed by an RFC. So that's very nice because it's completely standardized and you basically cannot go wrong when you want to implement it. And so at the end of this conversation, what happens is, so we get some information about who wants to send the mail to whom, and the main body of the mail, and at the end, the communication is terminated. So this is what we want to achieve. So, and it's important to understand here that these are just lines of plain text. So your mails are being sent by plain text. Now, when I started thinking on how to implement this, it looked like ZIO NIO is the perfect candidate to handle this for me, because what this library gives you the possibility, it's basically a wrapper around Java, NIO or NIO, and but inside the ZIO architecture and the ZIO framework. So you can use the ZIO effect system to basically perform Java NIO operations, such as defining a certain socket address and a port that you want to bind to. And from that point on, whenever a new connection appears on that port, it can be handled by some kind of worker or receive method that will pick up the information that is coming into this channel. And this channel is bidirectional. So you can receive information, but you can also put information back into the channel. And that's exactly what we need here, because it's like a question-answer type of protocol that we want to implement. And what you see here is an example. It's almost literally the same as what you can find on the ZIO NIO website. They have their own corner of the ZIO ecosystem. And this is how they demonstrate how to set up a service like this. And you can see on the penultimate line, the forever fork will make sure that this thing will keep on running for the entire duration of our application. And that's just what we want. So once we've started this, we would like to be able to interact with this client. So we need to be able to read from the channel. So we could do it like this. We could pass the channel around and then use ZIO streaming, because that's another, I didn't even mention this as a separate library that we'll be using, because it's so closely integrated to the ZIO core that it's super easy to use. And it's like a no-brainer to use for this kind of operations where you have certain amounts of data that are flowing in and also flowing out, to use a streaming solution. And this integrates very nicely with the NIO way of working. So in this case, we set up or read some chunks from the channel. This will give us chunks of bytes. Then we apply this flatten chunks method to make one giant stream of bytes. We pass that through a transducer to convert those UTF-8 bytes into a string. And then we use a sync fold left to basically concatenate all the small strings that we receive one by one into one huge string. And by the end of it, we will have, the end result of this method will be a string representing one line of information that we received in this channel. Now, the other way around is very similar, how to write a line of text. So with the same type of channel, you can do you can pick up the text, which is entering here as a string, get a character array out of it, and then also push that through a transducer to change it into bytes. And then using this for each chunk, you can write it in chunks, in parts of the whole stream into the channel. And so this will effectively write one of the lines of text that we want to send back to the client. Now, if you look at the protocol, so this is one line of information that we might receive from the client. So there's a mail from colon, and then there's some kind of name. So we need to think about how we're going to parse this information, because, as I said, it follows a strict protocol. But still, we will have to decipher this line and see if it's about a mail from, or maybe a recipient to, or if it's about the body data. So we have to do some kind of parsing. So let's say that we've read one line of information from the client. We now need to put it through some kind of parsing thing that will give us an object that we can work with, which will represent the text that just came in. Now, so I'm going to cheat a little bit here, because I said we would stay in the ZIO ecosystem. But so here I'm using the fastparse library, and of course I don't expect you to read all of this. This is just to give you an idea of what is involved in writing a parser with, in this case, fastparse. A really nice library, and with what you can achieve with the fastparse is you can give it a string, and you can give it like a prescription. That's what we're seeing on this screen here. And you can ask it to sequentially go through the string, see if it matches the prescription that you defined. And if that's correct, the parsing will have succeeded, and you can ask it to convert the text into some kind of object that you find useful, right? So, but now I hear you saying, well, but we would stay in ZIO. Okay, right. That's a fair question. So I can argue here that we are staying in ZIO because this fastparse itself has it's a very lightweight library. It has no hidden dependencies. There's no big effect system behind it. It doesn't create new threads or anything of that kind. So it's basically plain Scala. So we can just invoke it. And when it's done, we can lift the result into our ZIO effect system and work with it. And this is a way how we could do that. So we could inspect the parsing result. And when we see that it succeeded, so we have a successful parse result, we can create a zero effect by zio succeed. And if it failed, we can hand back an error. So in this case, just to remind the example that we started out with, so this line of text could be using this fastparse library. It could be converted into just a basic case class called mail from, with one attribute called from, which would be the person who is sending the mail. And well, in this case, it's extending a trade command because there are different types of commands that we want to have parsed. Right, so that's about SMTP. So we use the ZIO NIO to interact with an SMTP client and to receive an email. And now, of course, we have to keep a hold of that mail that we just received, so we can put it in the correct inbox, and for the clients of this application to be able to retrieve it. So as an intermediate object, we need some kind of message store, and what we'll do is use the zio-ref as a very easy way to just put something into an in-memory storage solution. So I didn't do anything fancy with persistence. I didn't know that ZIO cache existed, otherwise I could have used that maybe here. In any case, zio-ref is just a very convenient way to keep hold of a certain data structure also for a longer period of time. And what happens in a section of code that you see here is I defined a service object, and in it I have a method store message that I can use to put the message in a map that I put into the ref. So this map is the thing that will be stored in memory. And in the map, I use the email address as the key, and the value will be a message list. So I have to check if the list already existed. If it did, I'll add the message to it. And if it didn't, I have to create the list. So that's all that's happening here. So there's a little bit of semantics here when you work with the ref. So you can see this store.update. It takes with this underscore the current value of the ref, and then it adds something to it because it's a map. Now, and by using this service pattern, I can instantiate this guy once and then pass it into the SMTP server, and the SMTP server can use it to store the messages as they come in. Now moving on to the next part, the web interface. So what are the options here? And this is an interesting area because there are some options, and let's talk about them a little bit. So there's something called UZ-HTTP or micro Z-HTTP developed by these guys at Netflix. It was presented last year at Functional Scala. And this is a very interesting library, but these guys don't really do a great job at marketing themselves because they answer their own question if you should use it by probably not. So, okay, fine. There will be reasons that they don't really want us to use it. That's fine. But it would be a ZIO-only solution if you really want to build a web layer in ZIO itself. But, well, usage seems to be discouraged. Another option is to use existing Scala web layers. For example, HTTP-FRS would be a great choice. And there are interoperability libraries to make the connection between ZIO and HTTP-FRS, and that's fine, especially if you already know HTTP-FRS. Well, I don't, and I started looking into it because it seemed like a good solution to me. And I got a bit scared off by its functional programming all the way. And before I knew it, I was looking at this, for example, this Kleisli thing to get an authentication object from a request. And this was too much for me. You know, you remember I came from a Java background. I'm still learning this functional programming thing. I think if you are used to this kind of way of working and you are happy to work with these functional objects, fine. And it's probably a great library. But I decided to keep looking. Well, I do have some experience with akka-http, great library, it works just fine. And there's also interoperability for akka-http, and you can use it. The disadvantage here is that if by connecting your ZIO app to akka-http is that you're gluing the ZIO effect system to your akka actor system. And well, for me, that's a bit of uncharted territory. What would happen to your thread pools? Would they, you know, fight for the same resources? Would they compete for it? So that's something, you know, you're a bit on your own to understand how your system would behave at runtime when you put these two systems together at the same time. Now, it turns out there's another option, and it's called gRPC. And so the order of the slides is wrong here. Okay, yeah, so ZIO gRPC is a library that is fully inside the ZIO ecosystem. And it's the main author who wrote it is the same guy who also did the protobuf implementation for Scala. It's built with ZIO and ZIO streams. And so what it will do, it will generate code for you that you can run on the server and on the client, because you need to have both ends of the communication. And the absolutely mind-blowing thing here is that this, well, client, probably also the server, but at least the client, it can be compiled to JavaScript. So that means that you can run the gRPC client in a browser. But I just said that gRPC, this implementation runs in ZIO. So it means that on the server, you will have ZIO to run your server things. But in the client, in your JavaScript environments, you can also have ZIO. So you go from one ZIO to the other ZIO, and this is just mind-blowing. And well, you can do one-off calls, so from the client to the server, or from the server to the client, and you can even do streaming in both directions. So skip one slide back. So what I'm going to show you now is how you can use gRPC to define a service inside your server part of the application and to define the client in the front end. So just a super quick overview of gRPC. So it all starts out with a service definition in this service definition file. And so you define a service and you specify what kind of input parameter it takes and what you expect as a return type. By adding the keyword stream, you can define that you would like to have a streaming service. And both the input types and the return types you can specify yourself, or you have to, because they, so for example, the first service here, to get a mailbox for a certain user, the input object will be a get mailbox request with one argument, which is the username. And the return value would be a mailbox containing several entries and a total, which will give you the total number of mails for this user. So, and there are more definitions that are not shown on this slide, but just to give you the idea that this is the way to define both the services and the data types that will be flowing through these services. Now, what the ZIO gRPC will do is it will take this service definition. The service definition is basically enough to get started. You run the generation process, and out of it, it will generate the classes that you need, both at the service as at the client side. This is an example of the generated code for the service itself, so the server part. So it defines a new trait that you can implement in your own application code. And you will recognize, if you look closely at this densely populated slide, that the service that we just defined in one slide before, get mailbox is here, and the input type get mailbox request is there as well. And the return type is a ZIO with an R and a status, the error type, and mailbox, which would be a result of this call. So this is immediately derived from the service definition that we just specified, and that's great. And this is Scala code that it compiles, and you can use it in your server application to well, basically implement the protocol. Because whenever one of these requests arrives, you have to do something, which is in this case look up the messages for this particular user. So we're using the same MessageStore we just created a few slides back. Ask it to give us all the messages for a particular email address, and then we can return it. And you can see that the return type is in this case just a URL of a mailbox. We don't expect it to fill. And the mailbox contains the entries, mail entries for this particular user. So that doesn't seem too hard to implement. Now, the other end of the communication, like I said, so the gRPC client will live in the browser because we are going to develop it with the gRPC client Scala code, which will be compiled to JavaScript. And also, we get some generated Scala code with an object that we can use in our own code like this. So here, this is the same service, but seen from client perspective. So this is how you interact with the server by invoking this service. And we could use it like this, for example. So we could invoke the getMailbox method on the mailbox service client and stick in some kind of username, and it will interact with the server, and we can wait for the response and handle it. So that's fairly easy. And of course, we have to do something useful with that result. So for this purpose, I added a queue. I'll explain that later. And so when we receive a response, we would like to display all the emails for this particular user in a table. So we have to create this table somehow. And this is done in this add row method. And I'll show that here. And here we get to interact with, because you have to imagine that this code will run in the browser, so we can interact with the surrounding browser page. So for example, on the third line, you see dom.document. So this gives us a reference to the current HTML document. And we can look up a certain element called inbox. And if we find it, we can use that to manually add a new table row. And in that new table row, we can add more table columns. So this is quite an elaborate way to do it. There are, of course, libraries which can help you create this HTML code. I decided not to use that for this demonstration. And in the end, what I want to do here too is that when I build up this table with the individual mail entries, I want the user to be able to click on one of those rows. And when they do, the entire message should be loaded and displayed on the bottom of the screen, right? So I add an on-click handler to the table row that we create. And instead of directly fetching the message at that point, what happens there is I offer a new event to the queue that I created before. And this is a row-click event with the ID of the message, such that somebody who are listening to this event knows which message to fetch. Now, putting all of this together, you will see here that I can create a stream from the queue I just defined. And you'll see that when I receive a row-click event, that's when I know I have to go again to the mailbox service client, but now invoking a different service, which will fetch just one individual message with the full content. And at the end of it, I'm offering it to the same queue again with a new event, the message received event. such that we are sure that we don't get problems with interacting with JavaScript and the asynchronous gRPC code. So that's why we decided to put it into the same queue here again. And when the stream sees that we get a message received event with the body as an argument, so the body is the message body, we can again use the DOM.document to look up the correct element to add the body. So this is how we interact with the data we get from the server and put it in inside the front end. And as I said, it's also possible to define streaming services, and this is even nicer because then once you establish this streaming connection between client and server, it means that whenever the server receives a new email, it can be directly streamed back to the client, and we can refresh the screen and see that we have a new email message. So that means that we have all the components glued together, so that's great. A little bit about how to deploy. Well, so to get from this Scala client code to JavaScript, you have to run this full opt JavaScript command. There are two. There's a fast way and a full way. Full is better optimized. If you want to know more about that, you have to check out the Scala.js documentation. You have to create some HTML and CSS files for this stuff to, to land into. And there was something I didn't know about, which is called Envoy, which you can use to proxy this gRPC channel, because it's not exactly the same as regular HTTP traffic. There's a bit more happening. So you need this Envoy to handle that for you. Now, before we go to the demo, there's this third library that I used to put this all together, and this is ZIO Config. So I'll quickly go through that because I'm running a little bit out of time. So adding ZIO Config, I come from an akka-http background, so I'm used to type-safe configuration files. You can use different formats in the ZIO Config. And so to the left, you can see my application conf. And this can be easily converted into a configuration object or configuration case class that I can use to get to the configuration values. And my application conf will contain my most used values, but I can still override them by this second line that you see on for the port. So I can specify at command line that I want to override the default value that I specified in application conf.
I'm going to play with my hair. I am going to say
so
I'm going to make mistakes.
How do we wire all this together?
Is going to be
you can see our somebody is not on mute.
And it'll all
several different objects glued together here. The configuration file, the MessageStore is created, the gRPC service, and then in the main logic, we just have to get the config from somewhere, start the SMTP and gRPC services, and then we are good to go. So just to show you how this looks like in the end, I created a pre-recorded demo just to be sure. What you'll see here is two terminals to the left. So the top one is the server log, and at the bottom left you see a command line where I will start to a command which will send an email to the server. And to the right you see this beautifully designed web interface where with a web page which contains the code that we just described. And what will happen is to the right, we'll enter some kind of a mailbox name, and then we'll send an email to it, and we'll see it appear. So here we go. We're going to send the mail to Scala. Initially, the mailbox is empty, and then we send it out. And it appears immediately, and now we want to be able to click on it and see the full contents. And there we are at the bottom of the screen, we see the message body. So nothing too spectacular here. It's just good to know that this mailbox, like we said, is created on the fly. So this will send to a username at this domain and see what the mail looks like. Right, so getting to the end of my talk here. So what did I learn while working on this? So I think it's possible to stay inside ZIO and get a lot of things done. This gRPC thing, for me, it was just great to see how you can interact from the browser all the way to the server and get useful things done. What I learned when I was working on this project is that when you're new to ZIO, you really have to work your way through the ZIO from right to left. And by that I mean is start with the success value. and then start looking at how to handle errors. And then as a final thing, try to understand the R, the environment type, because I find that to be the most difficult thing to learn when you're new to ZIO as to what it really means and how the type should align, etc. So start simple and just get used to the effect system and create simple values, and then work your ways up through the error values to the environment type. So the community is great. I asked some questions in Discord, got really quick and good answers. And well, as we are seeing these days, many more cool things are still coming. What are my next steps? So I got really inspired by doing this thing. It's something that I can actually use at work. We need this kind of service. So I put the code out on GitHub so people can take a look and maybe even contribute. And I also put it out on a service called Fizzle email. But there are many more things to be done, like maybe Dockerize it, add ZIO logging, etc., etc. So this is a list of the resources that I use to put all of this together. Like I said, the code is out there. The service, I should mention the fastparse project by Liao Ji, and also the ad hoc email server. This is something that used to exist as a service, but it was taken down by the developer. But this was my inspiration because it already implemented this same idea, but of course not using Scala or ZIO. And that's all I have for today. Thank you very much.